Hey math fans, we're on section 1.1.2. Let's get started. An irrational number is a real number that cannot be expressed as a ratio of two integers, or in other words, it can't be written as a fraction. Decimal representations of irrational numbers neither end nor do they repeat. Many times radicals are going to be irrational, like the square root of 2. There's no number, there's no rational answer to that. It will be an irrational number. What we're going to be doing in this section is we're going to be solving equations that have rational exponents using the reciprocal exponent. So down in the lower left-hand corner, I have x to the m over n equals b. If I want to solve for x, if I want to isolate that variable, I'm going to be raising it to the reciprocal power of n over m. And remember, you got to do it to both sides. Here are some properties for irrational and rational numbers. Here's kind of a cheat sheet. So if you have rational plus rational, you get irrational. Rational times irrational, you get irrational. However, the irrational wins. So I have r plus I equals I. There's no rational number that you can add to an irrational number to make it rational. It will stay irrational. However, when you add two irrational numbers or multiply two irrational numbers, you don't know if it's going to be rational or irrational in the end. Here's a quick review of some of the rules or laws of exponents. Remember, when you have two numbers that have the same base, you can add the exponents when you multiply them. However, when you raise a power to a power, that's when the exponents get multiplied. Example 1, simplify the expression. So I'm noticing both of these numbers have the same base, which is a. So that means that I can add the exponents. So we're going to identify that property. Oh yeah, it's the multiplication property of exponents where I add the exponents. Now you're going to have to find a common denominator because they're both fractions, but in the end, the answer will be a to the 27 over 10 power. Simplify the expression in example 2. Now notice they both have the same base again of b. So what's going to be different about this one is that we're actually dividing these numbers, where in the last one we were multiplying. So if we were adding the exponents in the last one, that means, you guessed it, we'll be subtracting the exponents here. Again, finding a common denominator. And once again, negative exponents mean that it's actually the reciprocal. So if you wanted to rewrite that final answer without the negative exponent, which would be fully simplified, you would say 1 over b to the 17 over 9 power. Now example 3 has 3 to the 1/2 raised to the 4/3 power. Now that's power of a power, or power to a power. So this is where we're going to be multiplying the exponents. So when we multiply fractions, remember you multiply across the numerator and across the denominator. So you're going to end up with 3 to the 4 over 6 power. And then, of course, you can simplify that fraction to 3 to the 2/3 power. Remember, if you're going to use a calculator to solve for your final answer or approximated decimal, remember to use those parentheses. So when you're punching in the values to your scientific calculator, make sure that you know where your exponent button is. Sometimes it'll be written like this, or it will be written with the caret symbol, which is kind of like an arrow pointing up. But make sure to use those parentheses. And there's your final answer of 2.08. This is what you should not do. This is the answer if you don't use the parentheses, if you decide to just raise 3 to the 2 divided by 3 power without the parentheses, you'll get 3 as your answer, which is incorrect. Example 4 has a savings account that's going to be accruing this interest, and it says, what's the annual interest rate? So the first thing we're going to do is obviously substitute the values in to the equation so we can solve for x. Now, x is going to be that base, which, if you remember, in an interest problem is actually 1 plus r or 1 minus r. And if we're solving for the interest rate, when we get to the end, we're actually going to have to consider that 1 as a part of our answer. Once you have the values plugged into this equation, you want to isolate what you're trying to solve. So I want x to be all by its lonesome. My first step is going to be to divide by 5,000. And so I have 1.2407 equals x raised to the 11 over 2 power. Then I can raise both sides to the reciprocal power. Because if I raise both sides here to the 2 over 11, that means I'm going to be multiplying those exponents. 11 over 2 times 2 over 11 will equal 1. And that will get x all by itself. Now remember, the question asks for the interest rate. And my answer for x is 1.040. But I got to not think about the 1. They just want the r. So really the interest rate is 4%, that 0.04 that's next to the 1. Example 5, solve the equation of x to the third root 4, or the fourth root of x to the third, equals 125. First thing you should do is rewrite the radical as a rational exponent. So we're going to write it as x to the 3 over 4 equals 125. Now, how do we solve for x? We're going to isolate the variable by raising, you guessed it, to the reciprocal power. So it's x to the 3 over 4, so I'm going to raise it to the 4 over 3 power, which also means I got to raise the 125 to the 4 over 3 power. Again, use those parentheses if you're going to be using your calculator. The answer is 625. And that's going to do it for this section. We'll see you in class.